Today we are reviewing statistics, your basic statistics, and refreshing your memory on the different statistical operations, the way to represent them. Some of this may be beneficial in your IA that you guys have that you should be consistently working on. So there's two different types of data that come with statistics. What are those two different types of data? What are the two?
Quantitative and qualitative.
Very good. You have quantitative and qualitative. The difference between the two, qualitative, those are like your categorical type of data. You know, what's your favorite type of candy? Your type of shoe brand that you're wearing. Okay, things that can't necessarily take a numerical value. That is your quantitative data. Quantitative data is data that takes a numerical value. Your shoe size, your height, the number of red cars in the parking lot, so on and so forth. With your quantitative data, because a lot of your statistical operations in your test do run off of qualitative data, there's two different types of qualitative data.
Discrete and continuous.
Exactly, you have discrete and continuous. Discrete and continuous. The difference between the two, discrete are things that can be counted, whereas continuous is things that can be measured. If we kind of connect the probability topic along with statistics, because probability and statistics go together, discrete data is what you would do binomial distribution with, okay? Because it's things that can be counted, like, you know, 50 batteries in a bag, or the number of times someone's going to shoot an arrow. Versus continuous was your type of data that you dealt with in normal distribution, a range over continuing amounts of time, or, you know, the certain milliliters of lemonade in a container or something like that. Okay, so discrete is data that can be counted. Continuous is data that can be measured. With your data, you can either have random or biased data. Okay, those words are kind of very straightforward, but random, everything has an opportunity of being chosen, being selected. Bias, you only go after a certain type of group. Okay. A few other key terms that went along with statistics: population, that is your entire group. Okay, your entire group. So all 1,574 students at Lake Wells High School, that's the entire population, that's the entire group, okay? A sample, though, is a smaller part, such as your IB students, your athletes, your women at Lake Wells High School. There's also different ways, different sampling methods. We talked about this. This was something that was actually new into the curriculum this year, the different types of ways that you can collect your data. This right here is important for those who are doing a statistics-based IA. If you are collecting data or information, it's important to say how you collected this data. Was it a simple random sample where everybody had an equal chance of being selected? Or was it systematic, which is when you're doing in random intervals, such as every third person that you interviewed to answer whatever your question was? Was it a convenient sample, easy to select or likely to respond? Did you keep all of your data just to the students in your class? Because, you know, they are more likely to respond because they know just how important the IA is, because they have to do one as well. Or was it just, you know, students in your class because they were readily near you, they were readily available? You have a stratified or quota sampling method. Both of those, they kind of go together because stratified is random, quota is biased, but the data is still collected from a subgroup where each group is represented fairly. So the easy example I can give of that is like if you're looking at taking data of Lake Wells High School, subgroups would be each of the classes: freshmen, sophomores, juniors, and seniors, okay? So those would be your subgroups, and you want to select 5 students from each of those classes. Well, stratify would be random. You're just going to pick 5 random students from each class, but quota would be biased. You want 5 IB students from each class to collect your data. But whatever the sampling method is that you chose, if you're doing statistics based IA, you need to make sure that you describe how you collected or how you chose the data that you chose. Once you had your data, it was put into a frequency table, okay? There's, of course, you have your simple frequency table, which is your table that just has whatever your X value is, such as, days of the week, and then the number of students that were late, okay? This would be an example of a simple frequency table because you just have essentially, one value, one day, so on and so forth. But your grouped frequency table, that's where you had equal groups, more than 5, but less than 15, and the groups cannot overlap. So let's say that you had like 0 to 10, 11 to 20, 21 to 30, and so on and so forth. This will be an example of a group frequency table. Let's say these represent the ages of teachers at Lake Wells High School, even though we have teachers that are older than 60 years old. All right. This will be an example of a group frequency table. And then of course, your frequency would be over here on the right-hand column. When you had these types of group frequency tables, they were used to create things like histograms, cumulative frequency graphs, and other things of the like. This last little bit is talking about how to use your frequency table to get essentially like that endpoint of each group. If you have this type of frequency table where the upper bound of one class and the lower bound of the next class are not the same, this is when you had to take the average of those two neighboring classes to essentially find where that bar, where that ending bar would be on your histogram, or where that point would be on your cumulative frequency table. So you would take 10, add it to 11, and then divide by 2 to get what? 10.5. To get 10.5. So 10.5 would be where on a histogram for this first group, you would start at 0, but then it would go to 10.5, not 10. Because in a histogram, the bars touched, there were no gaps in between them. The next boundary would be what for the next class? 20.5. You add 20 and 21, divide by 2, and then you would have where the next bar would end. And it would continue until you reach the very end. So speaking of the very end, what would be the end point for this last class? Like where would that last bar end if I were to draw a histogram?
They all have to be the same width, right?
They all have to be the same width.
So it has to be 60.5.
So it would have to be 60.5. It wouldn't end at 60, it would end at 60.5. Okay, and so then of course, you would have your frequency on your y-axis. Let's just say this was age. And then you would have age on your x-axis. It's always important that if you have to create the graph yourself, that you label your axes. You have a consistent scale along your x-axis and a consistent scale along your y-axis. They don't need to be equal, but they need to be consistently spaced out, okay? So a good one like this would be like 5 and then 10, okay? And so then from there, you would be able to essentially draw your histogram. This is just a made-up example. I just pulled these numbers out of thin air. Here, that is an example of a histogram. All of your bars touch. Your points are at the averages of your upper and lower limits. Of course, if they are the exact same value, then you won't have to worry about doing any averages. So if it started at 10 for the second class, then it would just be at 10. All right, so let's take a look at this. You don't have to get these examples down. I am recording, so if you want to go back and get them, by all means you can. It says the table shows the number of the bicycles owned by 50 households. So you have your number of bicycles on the left, you have your frequency in the middle column, and then you have your cumulative frequency. What does cumulative mean?
They all add up to the population.
They all add up, okay? So you start at 3 because you had 3 households, three households that had no bicycles, but then you add the 7 to the 3, and that's how you get 10. 10 plus 12 gives you 22. 22 plus 14 gives you 36, and so on and so forth, okay? But no matter what, in a cumulative frequency, all of these values should add up to equal, or that last entry in your cumulative frequency should be the total number of people that you interviewed, okay? So using that, you have to write down the value of T and the value of W. What would be the value of T and what would be the value of W? Go ahead.
T is 8.
T is 8. How'd you get 8?
I added up 3, 7, 12, 14, 4, and 2, and then subtracted that from 50.
Very good.
Equal the 50 households.
Very good. So you know that all of those have to add up to equal 50, so that's good. So then you get 8. So if I know that this is 8, then W has to be what? 48, because W represents the cumulative frequency between 4 and 5, and so 40 plus 8 gives you 48. Questions on this? Of course, this is a part A, so there'll be more to go along with this question, but I was just pulling this out to make sure everybody understood with the frequency table here, okay? With statistics as well, came your measures of central tendency, mean, median, and mode. The words haven't changed since you were in elementary school when you first learned about them. They just maybe get interpreted a little bit differently once you've added in your different types of data. What does mean? Mean?
Average.
It means the average. That's when you take all of your values, you add them up and divide by however many you have. Median?
The middle.
It is the number in the middle, but you have to be careful. It's the number in the middle when your data
Is all in like numerical order.
is all in order, okay? Because sometimes you might be giving your data and it might be all your numbers all over the place. So you want to make sure that they're in order for you to find the actual middle entry. And lastly, mode means
Most.
the most, the one that appears the most, okay? Hasn't changed since 3rd grade. It's all the same. So let's take a look at this example. This is the number of passengers in the first 10 carriages of a train are listed below. When you look at this data, is it in order?
No.
Definitely not, but it does represent 10 carriages. It says the mean number of passengers per carriage is 5.6. What does mean? Mean again?
Average.
The average, that means I have to add all of these numbers up and then divide by however many we have, and that's going to equal my mean, which is 5.6. How many pieces of data do I have?
10.
10. So let's do that right now. Let's add them all up.
What do you need for the numbers that are in?
Okay, so I have 48 plus, what's P and P, 2P? Over 10 equals 5.6. I am in the process of answering part A to calculate the value of P. So multiply by 10. Subtract 48.
And then you divide by
So P is equal to 4. Now I ask you to find the median number of passengers per carriage. Well, in order to do that, I need to put in order. So that's 3. And then 4. I got 3 of those. I got 1 5, 2 6s, I think, and 3, 8. Yep, that's all 10. Y'all remember that formula to find median from last year?
I wrote down n plus 1 over 2.
Exactly. N plus 1 over 2 will help you figure out where your median is located. N represents the total number of people that we, or the total number of pieces of data that we have. So N is 10. 10 plus 1 divided by 2, that's 11 over 2 or 5.5. That's where I need to go to find my median. 1, 2, 3, 4, 5.5 would be halfway in between 5 and 6. So my median is going to be 5.5. Before anybody asks, no. Just because I do n plus 1 divided by 2 to get 5.5, that's not necessarily the median. That's where I need to go inside of my data to locate the median. It just happens to be 5.5.
So if it would been, in the 7 instead of the 6, that would have been, the median would be 6.
Exactly. It was a great question that said if the 6s were 7s instead, then the median would have been 6 instead of, 5.5. So it's really about the location, not necessarily what you do when you do the formula. Now, if the passengers in the 11th carriage are also included, the mean number of passengers per carriage is increased to 6.0. So we're adding in a different carriage now. Determine the number of passengers in the 11th carriage of the train. Well, that means I need to take the first 10. I need to add it to the 11th carriage. And now I'm going to divide by what?
11.
11, because now I have 11 carriages that I need to take into consideration. And the mean, once I do include that 11th carriage, is 6.0. What was the sum of all 10 of those carriages, the first 10 carriages?
56.
56. You can either get that by literally adding what's over here in the blue, or remember when we multiplied 10 by 5.6 and we got 56? That was our sum right there. Solve this out and tell me what X is going to equal. So X is equal to what? 10, exactly. So there we go, incorporating mean and median. Even though it didn't ask, what would be my mode for this example? It didn't ask, but what would be my mode?
8.
Sure?
4.
It will be, there's 2 of them that have the same amount. So your mode would be 4 and 8. You would have to include both because they both have the same largest amount. So it'd be 4 and 8 for the mode.
So the times that it happened, not the numerical value inside.
Say again?
So it's not the, there's the times it happened, so 3 times 4 and then 3 times 8, not the number that is highest.
Correct. Question was, is not the number that's, so even though both of those showed up the same amount of times, is not the higher number? No, it's both numbers since they both showed up the same amount of times. So 4 and 8 for your mode. A survey was carried out on a road to determine the number of passengers in each car, excluding the driver. The table shows the results of the survey. Is this data discrete or continuous?
Discrete.
It is discrete because this is stuff that can be counted. Like you can literally look at the car and be like, okay, there's 3 passengers in that car, there's no passengers in that car, so on and so forth. You can actually count it. It's not something that can be measured. What is the mode?
0.
It will be 0. When it comes to mean, median, and mode, you always look at how the number of passengers as your respective answer. So since 0 showed up 37 times, that is the number of passengers that had the highest frequency. Okay, that had the largest frequency. So so 0 would be your mode. It's the passenger, not the actual number of cars. Then it says use your graphic display calculator to find the mean and the median. Okay. I included this one in our review because you guys are able to use your calculator the entire time. It's important that you remember how to use your calculator to type in all this data. And it has been a while, so that's why we're doing this. I'm going to include the key press history, so then that way, if you happen to get lost in what I'm talking about, it's all right here, all the buttons that I press. Where do I go to type in my data? Who remembers? I got to go to stat, and I have to go to edit because I need to go to my list. Unfortunately, my list have things in there, so I need to clear them out. Clear, not delete. I go up to the actual title column, I press clear, and it empties everything out. On the day of your exam, your calculator is going to be reset. So all of your tables are going to be empty. All of your matrices are going to be empty. Your diagnostic is going to be turned off. So you won't have to worry about clearing anything out. You'll just have to remember to type certain things in and to turn certain things on. What do I put in L1?
The number of passengers.
I put the number of passengers. Actually, hold on. I'm gonna start over, sorry. Stat, edit, clean columns. So I put my number of passengers in L1, so that's 0, 1, 2, 3, and 4. Hopefully everyone's doing this as well. Go over, why are you not going over? There you go. And then what I put in L2?
The number of cars.
The number of cars, so that is 37, 23, 36, 15, and 9. So where do I go now to get all of my information?
Second stat and then median.
Not second stat. I go to stat, I go over to calc, and I go to 1 bar stats. That stands for 1 variable statistics. For the older calculators, you are going to have to type L1, L2. You are going to have to physically type out L1, L2. For those whose calculator is a little bit more advanced, your list should go in L1. So the number of passengers, your X variable. In frequency list, we do have a frequency. That's the number of cars that showed up. That is our frequency. So we need to have L2. So second 2 gives us L2. Second 1 gives us L1. And then we go to calculate. All of this information pops up. Who remembers what symbol means mean?
Symbol mean?
Yep.
The X with the line.
The X with the line on it. That symbol, the X with the line, means the mean. Who remembers what this symbol, like that little circle with the X, what does that stand for? Standard deviation. And if you scroll down, there's your median, as well as all the information, min, Q1, median, Q3, and your max. So what was the mean for this problem?
The mean was 1.47.
1.47? Can I get confirmation? Or do I need to go back and pull up my calculator and scroll back up to where mean is?
No, it's 1.47.
Okay, thank you. And then the median?
1.5.
Here's another problem. Here's an example of a histogram. Okay, as we can see, it says consider the, I'm trying to include this so it doesn't block. Okay, consider the histogram for the distribution of time t in minutes of telephone calls that Helen made last week. So you have the time as your x, your number of telephone calls as your y-axis. But if you look down here, you got your x value for time, and then you have your frequency, which represents the number of phone calls. Part A says complete the frequency table for this distribution. 0 to 5, how many?
12.
12,
Okay. Between 5 and 10,
4,
4,
10 and 15.
6,
Good. And 15 to 20.
8,
8. Okay. Unfortunately, it doesn't tell us how many phone calls that she made in total, but you want to base it off of course, you want to base it off of the graph. Real quick, is this continuous or discrete?
Discrete.
Minutes, so it's continuous.
My X variable is time, so this one would actually be continuous data. Even though the number of phone calls, of course, we can count the number of phone calls, but it's the time range. That's our actual X variable here. And so this will be an example of continuous data. What will be the modal class?
0 to 5.
It'll be
0
0.
to 5 minutes.
Exactly. It is the class with the largest frequency. So 0 to 5. And you want to write exactly how it's provided to you in the table. Then it says write down the mid-interval value of 10 to 15. Mid-interval. That's a good vocabulary word. Mid sounds like what? Middle. And so it's actually you find the middle of that interval. What's the number that's in the middle between 10 and 15? 13. 12.5. And we get that by taking 10 plus 15 dividing by 2. Essentially, we're trying to find the middle. We're trying to find the average of the class. That is supposed to trigger you to help you with D, which says use your graphics display calculator to find the estimate for the mean time. You will always find an estimate when you're dealing with group frequency tables. Why? Because I don't know exactly what the 12 phone calls were and their time length. I know that they were between 0 and 5. I don't know if one of them was 1 minute, 3 minutes, 4 minutes, I don't know. And so it's always going to be an estimate. And because we found the mid-interval value of this class, you always use your midpoints when you are estimating the mean. Is it coming back to you guys? You remember doing midpoints?
Yes.
Okay, so you need the midpoints for each of your classes in order for you to estimate the mean. So what's the midpoint of the first class?
2.5.
The second?
7.5.
And the last?
17.5.
I take the midpoints and I use my frequency to calculate my mean. So I go back to stat, I go to edit. I want to clear out this data. This data is not going to do me any good because that was for the last problem. So again, I go up to L2, I press clear and enter. That's how I get rid of all my data. Go up to L1, press clear, and then enter. That's how I get rid of all my data. Don't press delete. This is what happens when you press delete. Why? This is there we go. When I press delete, it actually deletes L1. don't delete L1. What if you delete L1? Just go back to stat, go to option 5, and then don't click additional 5, and then click enter. So stat 5 enter takes you back, and it brings back L1. Okay? So when I type all of my data in, hopefully you guys have already done this. Can you guys tell me what the mean is?
9.17.
9.17, can I get confirmation?
Yes, ma'am.
Okay, so remember we put our midpoints in L1, our number of telephone calls into L2, and then our mean is gonna be 9.1 what? 9.17 minutes. You do not round your mean unless it tells you to round to the nearest minute or something like that, okay? So it's gonna be a decimal. Well, not always, but you don't wanna round it. I want you guys to do this one on your own. Calculate the estimate for the mean smoking age for the number of teachers at this other high school.
You got 41.47, and then there's a bunch of numbers after that. So I guess 41.5. Want to round it up.
That's right. So you have 41.5 years old, I guess. All right. Did you guys get that?
Yes, but I have a question. Would you know how like the cumulative frequency, would they ever give you that and then you have to calculate the mean using the cumulative frequency and not like the numbers that they gave you for the second row right here?
There's a possibility that you could be given the cumulative frequency instead of the regular frequency. But there would be like another column of some sort to let you know, or maybe a diagram to let you be able to find the regular frequency. But you always want to do like mean and median with the regular frequency, not the cumulative. So if you're ever given a cumulative frequency table, there's going to be some other piece of information that you'll be able to pull out the regular frequency so that you can calculate the mean.
Okay, thank you.
Yep.
Minus the top number, right? And you get the
I think that's actually coming up too. So remember, you want to use the midpoints of each class and then the actual frequencies, and that's how we got 41.5. Here's another one. I want you to try on your own. The number of hours that a professional footballer trains each day in the month of June is represented in the following histogram. You're writing down the modal number of hours and the mean number of hours. Real quick, because I believe I went over this. How many days are in June?
30.
There are 30 days in June. So knowing that information, that essentially means is that all of those frequencies should add up to equal 30. That's how you can check to make sure you pulled out the correct value for each of those bars, okay? Here, I can create the table for this particular histogram, right? I'll have my number of hours here, and then I'll have my days in June over here. What were my hours that they trained based off of these bars?
to 4.9.
4, 5, 6, 7, and 8.
Okay, so this one, so because it is dealing with hours and it is dealing with time, these actual points, they do exist at those midpoints along this centimeter paper. Hopefully you guys haven't forgotten that this is how your graphs are going to be represented Anytime you have to draw a graph yourself, they're going to give you centimeter paper. Remember, every 5 little lines is 1 centimeter, and then you base it off of that. So we are at 3.5 to 4.5. So, and then 4.5 to 5.5, 5.5 to 6.5, and then 6.5 to 7, and then one more. 7.5 to 8.5. How many days?
4, 5, 9, 8.
Okay, does that add up to equal 30?
Yes.
So then, yes, our largest class would be in between 5.5 and 6.5. You could have also written it as just, 5.5 to 6.5 because it didn't actually show you how to represent it. Either one would work. And then it says to calculate the mean number of hours. So you would take the midpoints. So you would have used 4, 5, 6, 7, and 8 along with those, and you do get 6.1 hours. Questions on histograms, frequency tables, cumulative frequency tables, before we move on to the next concept. The next concept deals with cumulative frequency curves. Cumulative frequency curves were the ones that look like this, okay? Where the top of your cumulative frequency curve represented your N, your total number of pieces of data that you had, okay? As always, you want to make sure that you label your axes by whatever they were represented. We use cumulative frequency curves to find quartiles, your Q1, your median, and your Q3. That's when you were first introduced to those formulas of N plus 1 divided by 4, N plus 1 divided by 2, and 3, the quantity N plus 1 divided by 4 for Q1, median, and Q3. You also dealt with percentiles. Of course, that separates your data into 100ths. So if you were looking for the 90th percentile, you would take your total value, multiply by 0.9, and go from there. The key thing, and I remember this very distinctly because no matter how many times I said it, some students will still do it incorrectly. I'm going to continue to say it in hopes that they will now do it correctly. When you use these formulas, including with the percentiles, that does not tell you what your Q1 is. It tells you where to go along your cumulative frequency axis to actually find what your Q1, your median, and your Q3 were. So whatever this value was, when you would take N plus 1 divided by 2, you go to that value on your y-axis. You would draw a horizontal line over until it hits your curve and then drop down a perpendicular. Then this value on your x-axis would actually be the median for your answer, and so on and so forth. Once I did N plus 1 divided by 4, I would go to that value on my y-axis. I would draw a horizontal line over, then a perpendicular down. That value on the x-axis would be my Q1. The value on my x-axis is what is actually the answer to all of these. It's never what you get when you use the formula is the corresponding x-axis value. Does everybody understand that?
Yes, ma'am.
Yes.
Same thing with percentiles, same thing with percentiles. Interquartile range, that is where your middle 50% of your data lied, was in between Q3 and Q1. So you would subtract the 2, and that was your interquartile range. In the past, that was the only thing that was provided when it came to statistics and probability. To be honest, it is still the only thing provided in your reference booklet, but now they've actually also given you the formula for mean as well. So mean and interquartile range are the only things that are given to you in your reference booklet when it comes to statistics. Everything else you need to know. Everything else you need to know. So here's an example. The graph below shows the cumulative frequency for the yearly incomes of 200 people. You have your cumulative frequency on your y-axis. You have your annual income in British pounds on your x-axis. Use the graph. Anytime it says that, even if you draw your own graph and your graph is wrong, you still use your graph to answer these questions. The number of people who earn less than 5,000 British pounds a year. Well, here, I just go, I find where 5,000 is. I go up to see where it hits my curve, and then I draw a horizontal line over. How many people earn less than 5,000 British pounds? 20.
20.
Now I ask you for the median salary of the group of 200 people. Even if it didn't tell you 200 people in all of your different locations, okay, you can still look at the top of the cumulative frequency curve and see that it's 200. So I take 200, I add 1, divide by 2. What's that number? Is that my median salary?
No.
That's where I go to find it. So I go to 100.5, which is pretty much right in 100, so a little bit above it. I see where it hits my curve. I drop down a perpendicular, and I see that my median salary is what? Okay. Don't forget your units. I don't want you guys to lose the easy 1 point by not putting your units. Don't forget your units. Also, one positive, when you guys sit for your test, you will be given rulers, okay? So you'll be able to draw these very straight horizontal and perpendicular lines if you have to use, if you have to do this on your cumulative frequency curve. Now it says, what's the lowest income for the richest 20% of this group? Richest 20%. This is the percentile problem. What's 20% of 200 people?
40?
Okay. Now it says, what's the lowest income of the richest 20% of the group? So am I looking 40 people from the bottom or 40 people from the top?
40 people from the top.
40 people from the top. So I could do it. I could do this one of 2 ways. I could have done 200 times 0.2 to get 40, and then 200 minus 40 to get 160. That's where I'm going to go onto my cumulative frequency axis. Or I can do 200 times 0.8, and that takes me straight to 160. Okay? So depending on what the problem asks you to do, you could do it either way. But I want the richest income, the richest 20%. So clearly the amounts get larger. So the higher it goes, the more money you make, or more people, money. Whatever. So I draw my horizontal line over. I see where it hits. I drop down my perpendicular, and roughly, what's the income?
23,000.
23,000. Now with problems like this that don't have like the centimeter lines in there, they're gonna have a window. They are gonna have a window that it should be around this, but it definitely shouldn't have been 20,000. It definitely shouldn't have been 25. It needs to be something in between there, okay? Let's look at this one. It doesn't have your actual like a little description that describes what this represents, but I know automatically what is N.
80.
Because it's where the top of the cumulative frequency curve ends. So when I'm doing my median value, that's 80 plus 1 divided by 2, which is
80.5.
so I go to 40. I go to 40.5. Look at my scale. Every centimeter is 10. So that means every tiny line is what? By twos. Okay? Make sure that you peep that scale. Otherwise, it can really throw you off. All right? Draw down my perpendicular again. My median value is
30.
30. Remember, it always corresponds to the x-axis, those x values. How do I find my interquartile range?
Q3 minus Q1.
Q3 minus Q1. Gosh, I remember these problems so vividly. Students would literally use the whole n plus 1 divided by 4, and then the 3n plus 1 divided by 4. Y'all would take those values and you subtract them. No, remember, it always corresponds to the x value. So I'm looking, what's 81 divided by 4? 20 point what?
I'm sorry, 20.25.
And what's 3 times 81 divided by 4?
60.75.
I don't actually subtract these two from each other. I need to find what they correspond to first, and then I subtract. So 20.25, 60.75, drop down. Those values, those are my Q1 and my Q3. So my Q3 is 46, and my Q1 is, those are what I subtract to get my interquartile range, which is 26. That means that my middle 50% lie within 26 scores, between 20 and 46. Fine. Well, actually, probably you guys can't, y'all online probably can't do this because you can't draw on it yourself. I take 80, I multiply it by 35. What's 80 times 30.35? 20 what? So then I repeat to get my 35th percentile. And that answer is
24.
about 24. Here's a question. I don't know who, I can't remember who asked it, but somebody asked about the whole finding the mean and everything when you're given. When you're given cumulative frequency instead of actual frequency, which we are given in part D, okay? It says to write down the number of cars passing the camera with a speed less than or equal to 50 kilometers per hour. How many cars?
10.
It is 10. Remember, we get that 50 kilometers per hour. We can always go the opposite direction. Going from the actual X value over to the Y value. I know I'm a little high there, but it's okay. There we go. Now it says complete the following group frequency table for S, the speed. It is asking for the frequency. This curve represents the cumulative frequency. So keep that in mind. From 0 to 50, how many? How many cars were from 0 to 50?
10.
There were 10, so 10 goes here. Now it says from 50 to 70. Well, if I am at 70, I am here on my cumulative frequency curve, and then I am here on my y-axis. How many cars were between a speed of 50 and 70 kilometers per hour?
20.
It's 20. It is not 30. 30 represents your cumulative frequency. That means total, taking into account the previous group and now this group. So you have to subtract 30 from 10 to figure out how many actually lie in this interval. You're trying to figure out these different intervals. From 80 to, from 70 to 80, we were already given that information. We already told that this was 34. Do you guys see how they got 34? They took 64 and subtracted it from 30. That's how they got 34. So using that information, you need to do the same thing with 90. Take a look at where it hits for 90. What's going to be my frequency for 80 to 90?
Is it 41?
Not 41. You
26.
got to figure out how many cars are basically in between those two intervals. This is 64, and this one is 76. What's the difference between those two? 12. So I have to subtract. In a regular frequency table, you're essentially trying to figure out, okay, how many lie in each of these little intervals? I know 10 is here, 20 is here. I was told 34 was here, and I was told 4 was up there. All of these numbers should add up to equal what? Say it again. 80. So go ahead and write down my mean interval value and then find my mean speed and my standard deviation speed. Do that now. My mid interval value will be 60. Remember, you basically take the two, add them and divide. My mean, I'm putting all of my mid interval values into L1, all of my frequencies into L2. I know that this one is 60. What was this first one?
25.
Keep going. What about this one?
75.
So I put all those in L1, all of my frequencies in the L2 to get a mean of 67.5 kilometers per hour. And my standard deviation, you said, was 18.6. Perfect. Box and whisker. When you are drawing these yourself, make sure your whiskers do not go through your box. That would be counted wrong. There are 5 components to a box and whisker. What's the first piece right here?
Minimum.
Awesome. The start of your box. The first quartile. This middle line of your box. Not mean,
Median.
the median. This one, third quartile or upper quartile, and then the max, okay? Remember, the median does not need to be smack dab in the middle of your box and whisker plot. When it's off to the side, that essentially means that more of your data between your median and your Q3 lied in between whatever these data values were between 10 and 12, okay? This box and whisker breaks all of your data down into quarters. So 25% of your data lies in between your min and Q1, 25% between your Q1 and your median, 25% between your median and Q3, and then 25% in between your Q3 and your max. So if this area is really small, then that means that a lot more data was condensed between these two data values. And so how that would translate into like a cumulative frequency curve means it would be essentially a lot steeper when you got to those particular data values versus one that's a little bit more, spread out or increases a little bit more consistently. Some of your measures of dispersion, you had your range, very easy to find. You take something and subtract it from something. What are in those two blanks?
The maximum and minimum?
Exactly. I take my max and subtract it from my min. That's how I find my range, essentially, my data. Standard deviation is always found using your calculator, and it's the square root of variance. Y'all should remember that from the distribution, okay? It is the square root of variance. And variance talks about the spread of your data. We're not gonna do this entire problem, but I am gonna ask, is this data discrete or continuous?
Discrete.
It is discrete. Very good. Let's look at this particular problem. The weighting kilograms of 12 students in the class are as follows. What's the mode?
$99.
No, not 99.
I was trying to see the most. Okay.
Yes, the most. The most.
63.
5.
It'd be 63. That shows up 1, 2, 3 times. Okay. Now for this one, as one likes to kind of throw students off, especially if you're going to use your calculator to find your standard deviation. I don't have a frequency table. I just have my values straight. So when you have this, you'll just type in all of your data values into Y1. Okay. Type all of your data values into Y1. When you go to perform the steps to get like the mean and stuff like that. Okay, why is this stalling? I need you to act right. When you go to stat and you go over to calc and you go to 1-bar statistics, what do I need to fix on my calculator screen?
Take out L2.
I need to take out L2. L2 represents a frequency list. I don't have a frequency list here. I just have my original raw data. If I left L2 in there, and I think actually my lists were cleared out or whatever, but if you have something in L2, it's probably going to throw off your calculation. So anytime you just have just your actual raw data, make sure the only thing in 1-bar stats is something in list. Frequency list should be cleared out. So then that way it can accurately calculate your mean and your standard deviation, which is what for this problem? What's my standard deviation?
14.6.
14.6. So I want to do this example to show that. Over here, can everybody see the box and whisker okay?
Yes.
All right. So what's the median weight?
42.
Remember, it's that bar that's smack dab in the middle. Not in the middle, but in the middle of your box. My range, I find that by taking my max, subtracting my min. What's my maximum value? 58. I subtract that from my minimum value. What's my min? What's 58 minus 33?
25.
My range is 25. Estimate the probability that the weight of a randomly chosen female is more than 50 kg. Estimate the probability that the weight of a randomly chosen female is more than 50 kg. More than 50 kg would be this right here. What percentage of my data is that?
25.
So the probability that they're gonna weigh more than that, actually, sorry. So if this is 25% of my population, how many females did I have in this problem?
60.
What's 25% of 60?
15.
So it's gonna be 15 out of 60, which is essentially 1/4. Then if I select somebody randomly chosen, that's gonna weigh more than 50 kg, it's gonna be 1/4, because it's 25% of my data. Now use your box and whisker diagram to determine if the mean weight of females is less than the median weight. To determine if your mean weight is greater or less than your median weight, you're gonna have to look at the distribution of your data. You wouldn't be able to take your maximum value and your minimum value, like take them, add them, divide by 2, because you have, 25% that lie here, 25% that lie here, and 25% that lie here, and they're not all equally spaced out, okay? But what you can do, since they are broken down into quarters, that means that 15 girls are in each of these sections. You can take the midpoints of each of those sections. This one is 33, this one is 38. What's the midpoint between 33 and 38? What's the midpoint between 33 and 38?
35.5.
What's the midpoint in between 38 and 42?
$40.5.
Not 40.5, but just
I just got 40.
40. I need the midpoint between 42 and 50 and 50 and 58.
46.
And
54.
so these are the midpoints for all of your regions. There are 15 girls in each of those regions, and so you can estimate what the mean could potentially be based off of the fact of how the box and whisker plot is distributed. So if you do this and calculate what your mean is, you're gonna realize that your mean is not less than your median. Find my mean weight. You said 43.8.
Yeah, 43.9.
Can I get confirmation? You're using your box and whisker plot along with the distribution of each of these females. You don't know exactly what the weights were, but you know that 15 girls are in between your min and your Q1. 15 girls are in between your Q1 and your median, and so on and so forth, because your box and whisker plot breaks it down into quarters. This entire lesson covered all of your basics of statistics, mean, median, mode, standard deviation, cumulative frequency curves, histograms. Fox and Whisker. I'm almost certain that I might have forgot something, but you go back and you look at your notes and make sure that you know all of your basic statistics.